All right, let's look at homework 4.3, number 2, part C. All right, so this is the function given, and part C is asking for basically the inflection points and concavity. All right, so let's do that. So we need to take two derivatives. So let's take the first one. All right, first derivative, f prime of x is equal to, all right, so it says going to be a quotient rule, so going to put along. Alright, so then square the denominator. So you have that. Alright, derivative of the top is 2x times the bottom, which is x squared plus 1, and minus, and you have x squared on top, and take the derivative of the bottom, which is going to be 2x. Alright, so try to simplify that, and you will get, let's see, go here. All right, so multiply out, you have a 2x, let's see, cubed plus 2x minus 2x cubed. Right, on the bottom, you have x squared plus 1 squared. 2x cubed and 2x cubed cancel out. So you end up getting 2x on top. Then you have x squared plus 1 squared. Right? So we have to take another derivative. So f double prime of x, right? Which is equal to, right? So another quotient rule. Let's do that. So square the bottom. So x squared plus 1 quantity to the fourth power because it was already squared. All right, then derivative of the top is 2 and times the bottom. So x quantity x squared plus 1 squared, right, minus 2x times derivative of the bottom would be 2 in front, and the quantity x squared plus 1, and subtract 1 from the power, then multiply by derivative inside, so it's 2x. All right, so pull out what's in common from the numerator. So that's going to be, let's see, 2 is in common, so 2, and let's take that 2. So 2 is in common, and also x squared plus 1, so one of them, and here's another one. So you have x squared plus 1. All right, I think that's about it. So I'm going to just write down what's left over. So you have x squared plus 1 from the first term. Yeah, so we took care of that. All right, from the second term, you will see that you have a negative 4x squared. So negative 4x squared. And on the bottom, you have x squared plus 1 to the fourth power. Right? Then you can cancel x squared plus 1 and x squared plus 1, so it's going to be cubed. Right? Then the derivative is going to be, let's see, there's 2 there. Right? Then there's going to be 1. All right, so put 1 here. I already took care of 2. All right, then combine x squared and negative 4x squared, so it's going to be minus 3x squared. Right, and then you have a divided by quantity x squared plus 1 cubed. All right. All right, so let's set that equal to 0 to find the x coordinates of the possible inflection point. All right, so if you set that equal to 0, we can just set the top equal to 0. So you have a 2 times 1 minus 3x squared equal to 0. Divide through by 2, so I'll just cancel that. 0 divided by 2 is still 0. So you can see that, let's see, x squared has to be 1/3 is equal to 1/3. All right, so we take the square root of both sides. So x is going to be equal to plus or minus square root of 1/3. Right? So we have those. All right, so let's do a number line for f double prime so that we can observe the concavity. All right, so you have a negative square root of 1/3 and also positive square root of 1/3. All right. So let's look at the signs. So f double prime, right? So we're going to look at something smaller than negative square root of 1/3. So we'll probably try negative 1, right? So if you plug in negative 1, so negative 1, so it's going to be negative on top. And the bottom is always positive, so you're going to have a negative sign here. So it's negative here. And if you try something between negative square root of 1/3 and a positive square root of 1/3, I would probably try 0. So f double prime of 0. So if you put 0 here, top is positive, so it's going to be positive second derivative. All right, then we can try anything bigger than square root of 1/3, so we try 1. So you see that the 1 squared, so it's going to be negative. So it's going to be negative here. And top is positive, so it's always negative here. All right, so I'm going to just erase that. All right, so we have that. Then, so you can see that it's going to be, if you want to talk about concavity, so original function f is, all right, concave upward on the interval from negative square root of 1/3 to positive square root of 1/3, right? And a concave downward on, all right? So it's going to be negative infinity to negative square root of 1/3, and from positive square root of 1/3 to positive infinity, right? So that those are the intervals of concavity, right? And you can see that there's a concavity change. So right here at x equals negative square root of 1/3, so there will be an inflection point. And also here, concavity change occurs, so you have inflection point there too. So we just want to find the corresponding y value, so evaluate f of negative square root of 1/3. All right, so square that, it's going to be 1/3 on top over 1/3 plus 1. So it's going to be 1/3 over 4/3. Right, multiply top and bottom by 3, you get 1/4. Right, you see that they're going to get exactly the same value if you plug in positive square root of 1/3, because it's going to be still, if you get squared, so it's going to be 1/3 over 1/3 plus 1, so therefore it's exactly the same value. All right, so therefore we found two inflection points. Inflection points are, all right, so first one is negative square root of 1/3, comma 1/4, and positive square root of 1/3 and comma 1/4. Right, so those are the inflection points. Right, that's it. I hope that this was clear.